So this is the figure, right? In this example, what we have the two immiscible liquids. The density of this liquid is D and the density of this liquid is, right, this liquid is, this is the another liquid and this is the another liquid and it is 2D, right? This is D and this is 2D. So this is the cylinder, right? And this is 3L by 4 and this is L by 4, right? If the density D, the density of the solid is capital D and density of this liquid is D, this liquid is TT. So you have to find relation between small d and capital D, right? Such that this height in the figure is given as h by 2 and this height in the figure is given as h by 2. Is it clear or not? That is the question, right? So what to do? Tell me. If its density is D, so what is acting? The force, it is in equilibrium, the force mg will be acting downward. And what else force will be acting, Varsha? The force due to this displaced liquid whose density is D and the buoyancy will be B1, and due to this displaced liquid whose density is 2D and the buoyancy will be acting in the upward direction. So B1 and B2 will be acting. So at equilibrium, what the condition you will apply? The mg is balanced by V1 plus V2. Is it fine or not, you tell? What is the B1? Is the weight of the liquid displaced by this volume, right? And what is the B2? Is the weight of the liquid displaced due to this volume. So V1 is M1 G, right? M1 dash G, and this is the M2 dash G is equal to capital Mg. So I think G will cancel out. So what is the M1? M1 is the mass which is equal to volume into density. Whose density? You tell. Which is D or 2D? This is the portion. This liquid is displaced. What is the volume? What is the volume of this portion? You tell first of all. The volume is area, right? Suppose the area is A, right? Area is A, and what is the length? 3L by 4. So is this volume or not? If you consider this is the volume, this is the cylinder, the volume is area into length, and whose density will come over here? You tell. D, right? So it will be equal to A into 3L by 4 into D, right? Small d, plus the M2 dash. What is its volume? You tell. Area into L by 4. This is the volume V2. And what is the density of this portion? Say 2D, right? So A into L by 4 is the volume and the density is 2D, and this is equal to M. What is M? M is the mass of this cylinder. What is the mass? Say volume into density. Volume will be A into length L multiplied by density capital D. Is it clear or not? So you will see AL will cancel out. So what will be left? 3D by 4 plus 3D by 4, and this is 2D by 4, right, is equal to capital D. So here 5D by 4 is equal to capital D. Small d is equal to 4D upon 5. So this is the answer. So which option is the correct answer? So the D option is the correct option. All right, copy this. So in this question there is a cube, right? This is the water. Suppose the water is filled in a water tank and a block is a cube, right, is floating on this, right, like this. The cube is floating on this. Is it clear? And the density of this cube is 0.5 gram per cc, right? This is the density. So, and the side is 10 centimeter. If the side is 10 centimeter, can you tell me what is the portion inside in it? Suppose this is the V1, this is the V2, right? So at the equilibrium, the mg and the Buoyancy force will act. So Buoyancy is equal to what? Say mg. Is it clear? So Buoyancy will be equal to mg into m dash g. So m dash is equal to m. What is the m dash? Is the mass of the liquid displaced is equal to volume into raw water, right? And what is the mass? Capital M is equal to capital V and the density of the solid, right? So the density of the solid is given as, what is the volume of the cube? The volume of the cube is what? Say 10 centimeter, 10 centimeter into 10 centimeter, 10 into 10 into 10 into 0.5, the density of solid. What is the V1? Say x into 10 into 10 into x, x into 10 into 10, and raw water is 1, right? It will cancel out. So x is equal to 10 into 0.5, x is equal to 5 centimeter. So in equilibrium, right, in equilibrium, what is the distance inside the water? It is x is 5 centimeter. Is it clear or not? So this is the first condition. Now in this tank, on this tank, and it is the initial level of the water, right? It is the initial level of water. Now a body of mass m is placed on it. So what will happen? It will go down and the water level will come up when you put, right? Suppose it was the initial level of this block. Now when you insert some mass over this, suppose the level, this portion, this line, it means it goes down by distance. Suppose its distance is y. Is it clear or not? So what will happen then? So the level of the water will rise by what amount? Suppose when it go down, right, the water level will go up, and this is the displacement in the water level. It is given in the question, and how much it is? It is 2 millimeter. This is what? Say 2 millimeter. Is it clear or not? So you tell me, in this case the water level is now, and the displacement in the cube vertically down is y. Is it clear or not? The base area of the tank is given as the 15 centimeter square. And what is the area of this portion? The area of this portion is what? 10 into 10 is equal to 100 centimeter square. Is it clear or not, you tell? Right. So we have to find what is the mass if this water level is move up by 2 centimeter. When the cube comes down, right? So what is happening, you tell? This is the y portion, right? This is the volume. This is the volume displaced further by the cube, and this volume comes in this portion. Is it clear or not? First of all, tell me. This is the volume, further it is displaced, and this volume, right? This volume now, this is the volume displaced by the cube, and this come over here. Is it clear or not? And in this case, suppose this is the m dash, this is the m1, suppose. All right. Now in this case, what is the equilibrium condition? This is the equilibrium condition. This is the 2 millimeter. This is the y. So what is the condition? Initially, it was 5 centimeter. It was in the liquid. It was 5 centimeter. So what is the portion inside the liquid now? the portion inside the liquid is 5 centimeter plus y plus 2. This is 0.2 centimeter plus 5 centimeter plus suppose it is y centimeter. It moved down. So this is the volume displaced by the body in this case. Suppose this is the V1. Now, if you apply the equilibrium condition, what is the equilibrium condition? The mg, this is the mg plus m1g, m1 plus mg, and the Buoyancy force is B. So Buoyancy force must be equal to m1 plus capital Mg, and which is equal to what? Say m dash g, gg will cancel out. So mass of the liquid displaced is equal to m1 plus small m. This m1 we have to find actually. M1 is equal to what? So volume displaced, right? The volume displaced multiplied by density of water is equal to m1. The m1 we have to find, and what is the capital small m? Is equal to volume of the solid into density of solid. The density of solid is 0.5, right? What is the volume displaced now? Tell me. The volume displaced is, this is the 10 centimeter. This is what? Again 10 centimeter. And what is the width inside the water? 0.2 plus 5 plus y. 0.2, right, plus 5. This is 5.2. I can write this is 5.2 plus y into length into width into 10 into 10 into raw water is what? Say 1. This is the m1 plus what is the volume of this solid? It is 10 into 10 into 10, and the density of the solid is 0.5. Is it clear or not? You tell. So if you simplify this, right, 5.2 plus y into 100 minus 500 is equal to m1. So this m1 we have to find. If we are able to find the displacement of the y, then we can find the m1 value. To find the y value, right, this which displacement of the cube inside the water after placing the m1 mass on this. How to do that? Conservation of volume mean this volume comes to this portion only. So what is the volume displaced by the cube? The volume displaced by the cube, volume displaced by cube, displaced by cube is equal to volume rise, volume raised, right? So what is the volume displaced? 10 into 10, 10 into 10 into y. This is the volume displaced, 10 into 10 into y, and where it volume comes? It volume comes in this portion. What is the volume? Volume is the area. What is the area? This is the 1500 minus the area of this, and this is what? 100 centimeter square. So what is the area of the volume rise? Is equal to 1400, right? 1500 minus 100. I am writing this side, 1500 minus 100. And what is the length rise? It is 0.2, right? So it is 100 y 1400 into 0.2. So y is equal to what? It will cancel out. 14 into 0.2 is equal to 2.8. This is the value y is 2.8 centimeter. So now therefore m1 is equal to what? 5.2 plus 2.8 into 100 minus 500 is equal to what? 800 minus 500. So the mass is 300 gram. So the mass of this block which is placed right over the block, so that when it comes down, the water level is rise by 2 millimeter. Is it clear or not? So this is the solution. So in this question, listen one thing. Suppose we have a jar and the water is filled over here, right? And it is placed on a weighing machine. Suppose it is playing on a weighing machine, and this is the weighing machine, right? Like this. This is the weighing machine. This is the reading. So what will be its reading of the weighing machine? You tell. The reading will be equal to, suppose this is the jar, right? This is the jar and this is the water. So total mass is what? Say before anything, it is 700 kg weight. Kg weight means 700 kilogram is the reading. Now what will happen if 100-gram body, right? Sorry, the volume is 100 gram when it is inserted by anyhow, and the density of body is not given, right? And this is the again placed on the weighing machine. So can you tell me what will be its reading? Its volume is given 100 cc, right? So I ask you the one question, the reading will increase or decrease? You tell. It will increase. By what amount it will increase? Listen one thing, when you dipped the body, right, the level will, initial level is this, when you dipped the body, the 100 volume, 100 cc volume will rise up, right? So although it is the mg already acting over here, and the mg is equal to what? Say 700 g, you can write like this, right? So what extra force is acting when it is dipped, or whether it is sinking or whether it is light, it will move up, does not matter. You tell me, the on this body what will happen? See, the Buoyancy force will acting. So the same Buoyancy force acting by the liquid on the body in a what direction, and because of this body, the same Buoyancy force is acting on the liquid also. Are you getting or not? When you dip the body, you apply the force, right, equal to the volume of equal to the weight of the volume displaced, right? So the same Buoyancy force start acting. Initially it was mg, capital mg was acting over here, that is 700 kg weight. So can you find the Buoyancy force which is increasing the reading? So Buoyancy force is nothing but equal to the weight of the liquid displaced. What is the weight? Say volume into density of water into g. What is the volume? Say 100 cc into 1, right, into g. So B dash is equal to, this is in Newton, right, or you can write kg weight. So extra, this is the Buoyancy force which is extra exerting by the volume downward. So what will be the reading? 700 kg weight already due to the weight of the jar and the water plus Buoyancy force. So reading will be equal to 800 kg weight. Is it clear or not? Copy this. So the same type of the question I am explaining you, although it will be given in your sheet. For example, suppose we have a spring mass balance like this, right, and this is the body of the 2 kg, right, it is handling, and its density of solid is 800 kg per meter cube. Suppose this is made of brass and it is hanging, right? So what is its reading? This is the spring balance. The reading will be equal to what? Say 2 kg weight. 2 kg weight means 2 kilogram weight it will show. Now there is a beaker, right, like this, and this beaker is filled with water, and the density of the water you know very well, 1000 kg per meter cube, and the reading of this is the spring balance, this is spring balance, and this jar with water is placed on the weighing machine, and the reading is 8 kilogram, right, 8 kg weight. Are you getting or not? Now if this spring, this block is dipped completely in the water, right, now the block is lowered, completely in water. What is the reading? what is the reading of spring balance, of spring balance and weighing machine, right? Weighing machine. I think question is clear. First copy this question. So when this spring balance is lowered in this right beaker, what will happen, you tell? This is the beaker and this is the block, right? Completely lowered, right? This is the spring balance and the block is completely lowered in the water. All right. And this is connected to the weighing machine like this, right? Tell me, how many force will act upon this now? Say the mg, the spring force and the buoyancy force. Is it clear or not? So the spring force will be the reading of the weighing machine. So Fs plus buoyancy is equal to what? Say mg. So the spring force will be equal to mg minus buoyancy will be equal to what? Mg minus m dash g. Is it clear or not? Listen one more thing. So can you find the buoyant force over here only? Buoyant force. What is the buoyant force? Varsha is equal to weight of the liquid displaced. What is the weight? Tell me, what is the weight? No. Weight of the liquid. What is the buoyant force is equal to weight of the liquid displaced. The weight, this is the of the block, the mass into g. What is the m dash? Say mass of water displaced. A mass is equal to volume into density. Whose density? Say water density. What is the volume? How to find the volume? We can find the volume. How? M is equal to volume into density of solid, because the mass is 2 kg, volume is V, the density is 800. So what is the volume? 1 by 4000 meter cube. Is it clear or not? So the buoyant force, the volume displaced liquid is equal to volume of the solid, because it is completely dipped. So what is the volume? 1 upon 4000. The density 1000. G value is 10. So this is 10 upon 4 is equal to what? This is 5 by 4, right? It is 5 by 2 is equal to 2.5 Newton. Is it clear or not? 2.5 Newton. If this is the 2 by 2.5 Newton, right? So in kg weight, 0.25 kg weight. Is it clear or not? Right? If mass is 25 kg, so it is like 2 kg weight, and it is Newton. It is in Newton. Then 25 g is equal to 250 Newton. You must understand. If 250 Newton, when you want to convert into kg weight, just divide it by g. So it is 2.5 Newton. So to convert in kg weight, it is 0.25, right? Kg weight. So this is the buoyant force. So can you tell me what is the initial mg? The initial mg was 2 kg weight. I am writing this. Minus what is the buoyant force? Say 0.25 kg weight. So what is the reading? The 1.75 kg weight. Is it clear or not? So the spring balance here will read 1.75 kg weight. The weight will be reduced or not? Yes, it will reduce. By what amount? Say by mg only. And now what about this reading? Although the weight of this liquid and jar was acting 8g downward, but together with this, the buoyant force is also acting over here. The buoyant force is also acting. So if you consider the free body diagram of liquid and of this jar only, right? So the 8g plus the buoyant force is also acting on this. So the reading of weighing machine will be equal to what? The 8 kg weight, 8 kg weight plus Buoyancy force. So what is the Buoyancy force? 8 kg plus Buoyancy 8 kg weight plus 0.25 kg weight. So the reading will be 8.25 kg weight. Is it clear or not? This is the reading of the weighing machine. This is the reading of spring balance when it will dipped completely. All right, copy this. So this question can be solved or can be viewed in other point of view. For example, listen. First, you find the Buoyancy force, right? And the other way to solve this question, right? Listen one thing. Suppose this is the spring balance, right? This is the spring balance. This block is lower down. So no doubt the reading of the spring balance will be the spring force. And this is the mg and this is the Buoyancy force. So the Fs plus B is equal to mg and Fs is equal to mg minus B. It is 2 kg minus 0.25. So it is 1.75 kg weight is the reading of the spring balance. This is correct. All right. But listen one more thing. If you consider this is the weighing machine, suppose, right? Although the weight 8 kg plus Buoyancy force we have taken into account. If we consider this is the system, right? This is the system. Are you getting or not? So in this system, what is the weight of the liquid plus jar? Say it is 8 kg plus the weight of this solid body is also equal to what? Say 2g. So what is the total weight you tell? The 8g plus 2g. If this spring was not there, what was the reading of the spring balance? Say 8g plus 2g is equal to 10g. Are you getting? But there is an external force. The Fs is acting. Now this Buoyancy force is the internal force and we can ignore this. If you consider this is the system, right? 8g plus 2g is acting downward, right? And the spring force is acting upward. So this is the net force acting downward on this weighing machine. So it is equal to what? 8g plus 10g, right? And this is equal to 10g. And what is the spring force? The spring force is 2g minus, right? This is 2.5, 2.25g, like this. So this is equal to 1.75g. So is equal to 8.25g. So in this case, you can also solve. You can also solve in this way. The net force acting is 8g plus 2g minus spring force. The answer will again come to be 8.25g Newton, or reading will be 8.5 kg weight. Is it clear or not? So in this way also we can solve this question. Otherwise, the total weight plus extra force Buoyancy you will have to add. The Buoyancy is 0.25 kg. The answer will be the same. In some books, solution will be given in this way. In some book, the solution is given in this way. So both solution you must understand, right? Copy this. So listen one thing. One more question I am giving you, right? For example, suppose this is the liquid. Suppose this is the water, right? This is the water. The density is 1000 kg per meter cube, right? And there is a spherical body, right? And its density is less. The density is 700 kg per meter cube. Is it clear or not? So when it is released from rest, so what will happen? You tell. It will move up or go down? Tell me. It will move up, but it is tied with this string, right? This is the string over here, and you have to find tension in this string. Find tension in the string. Is it clear or not? First, if this is at rest. Initially it is at rest. In the second part, if this system is accelerated upward, right, with acceleration 2 meter per second square. Again find tension in the string. Is it clear or not? Copy this. So how to solve this question, you tell. When it is at rest, right, I am making the free body diagram over here only. So how many force will act upon this? The Buoyancy force will be acting upward and the mg will be acting downward. Which force is greater, you tell? Buoyancy force or 10 mg? The Buoyancy force is greater than mg, so it will move up, therefore the tension will be in this direction. So for when the body is at rest, the free body diagram, the tension will be like this, the mg will be like this, and the Buoyancy force will be like this. Is it clear or not? This is the mg. Fine. Although all the forces, this is the tension, this is the mg, and this is the Buoyancy force, will act on the same line. At equilibrium, what we have to do? The Buoyancy force must be equal to mg plus tension. So what is the tension value? Is equal to Buoyancy minus mg. How to find the Buoyancy? Is the weight of the liquid displaced. Is it clear or not? So wait for 1 minute. So the m is not given. You can assume to be the mass of this body is the 10 kg, right? 10 kg is the mass of this solid sphere, you can assume, right? So if you take common mg, so m dash g upon mg minus 1. So this is mg, m dash upon m minus 1. The m is what? 10g. All right. And what is the m dash? Volume into density of water, volume into density of solid minus 1. Volume will cancel out. Density of water, density of solid, it will cancel out, minus 1. 10g, it is equal to 100, right? This is 5 by 4 minus 1. This is 100 into 1 by 4 is equal to 25 Newton. So the tension in the string when the body is when the system is at rest is equal to what? Say 25 Newton. Is it clear or not? Now see what will happen in the second case. If this system, suppose this system is accelerated. Now when you will sit over there and the system is moving up with the acceleration a, right? So the Buoyancy force is b, the tension is T dash now, and the G effective will be the mg effective. When it is moving accelerated with, if the system is accelerated upward, there was the upward, so the G effective will be equal to what in this case? Say G minus A. But the tension plus mg effective is equal to Buoyancy force. So T dash will be equal to B minus G effective. Is it clear or not? What is the Buoyancy force? Say m dash G effective minus m into G effective. Only the thing is that everything will be same. So mg effective, right, m dash upon m minus 1. Only the thing is that the G effective will change when it's move up. So that tension will be changed. The mass is 10 and the G effective what? G effective, wait for 1 minute. When it is moving up, right? So G effective will be G plus A. Is it clear? So it is 10 plus 2 is equal to 12 meter per second square. So I have to write 12. What is the m dash? M dash upon m, V will cancel out. This is 5 by 4 minus 1. Is it clear or not? So this is 120 into 1 by 4. This is the 30 Newton. Is it clear? So in this case, when it is accelerated up, only the G effective will be changed and the tension in the string will be 30 Newton in the second case and 25 Newton in the first case. This is the first part, this is the second part. Copy this. So in this question, listen one thing, the same type of the concept is asked, right? This is the sphere of mass m. The specific gravity is given as the 0.5, mean the density of solid and density of water ratio is given, and density of solid is 0.5 into density of water. This is the one thing, and this system is being accelerated and you are sitting suppose over here, and in the first case you have to find the tension in the string, right? So tension is over here, the mg is downward and the buoyancy is acting upward. So at equilibrium, the mg plus tension will be equal to buoyancy force, so minus mg. What is the buoyancy force? Say m dash g upon mg. What will you take common? You will take common, what is the mass? Mass is given. So mg upon m dash g minus mg minus 1. So mg, what is the m dash? It will be mg into m dash upon m minus 1. What is the m dash? Volume into density of water, volume into density of solid minus 1. So the m mass is given as the 2 kg. So 2 into g, volume will cancel out, water density, right? The solid density is 0.5. So it is rho water upon 0.5 rho water minus 1. This is 0.5, right? So what will be the tension then? 2g, rho water will cancel out, 0.5 minus 1, 2g, it is 2 minus 1 is equal to 20 Newton. So this is the first part. Wait for 1 minute. I had make mistake. What is the mistake? I have to take here the G effective. G effective. This is the G effective. This is the G effective. G effective. Right. So tension is equal to 2 into what is the G effective? The acceleration is 2 meter per second, upward or downward? Upward. So it is G plus A, 10 plus 2 is equal to 12 meter per second square. So I will take the value of the G effective is 12 and this is equal to 1.1 upon 0.5 minus 1, 24. It is 10 upon 5 minus 1, 24, 2 minus 1 is equal to 24 Newton is the tension in this string, the first part, right? Copy this. So listen one thing, in this case, in the second part, what is happening? This thread is snapped, it means it is broken. So then they are asking the acceleration of this sphere with respect to what? With respect to tank. So with respect to tank, how many forces were acting? Say mg, m into g effective, and what is the buoyancy force? B buoyancy force. So the acceleration will be upward direction. This is the A dash. So the net force is equal to what? M into A. What is the net force you will say? Tell me. I am making this figure with respect to tank. Are you getting or not? With respect to tank. So what is the net force? Buoyancy force minus mg effective is equal to m into A dash. What is the buoyancy force? Say m dash into g effective minus m into g effective, m into A dash. Is it clear or not? So the A dash will be g effective, I will take common. This is m dash minus m upon m. M dash upon m minus 1 into g effective. What is the m dash? Volume into density of water, volume into density of solid, g effective, right? Rho water as it is, right? What is the rho solid? It is 0.5 rho water minus 1. What is the g effective? G effective is 12 over here. So what is the acceleration A dash? Mean the acceleration of ball with respect to tank. You are sitting here and it is moving up, right? So it is equal to 1 minus 1 into 12. It is 10 upon 5 minus 1 into 12. 2 minus 1 into 12. So it is 12 meter per second square. Is it clear or not? So this is the acceleration of the ball with respect to tank. This is asked in the question, but they may ask the acceleration of block of ball with respect to ground. If somebody asks the acceleration of ball with respect to ground, then what will you say? With respect to this, the acceleration of ball is 12 meter per second square, right? And this tank is also itself moving with acceleration 2 meter per second square. So the acceleration of ball with respect to ground is equal to a dash plus a, right? Is equal to 12 plus 2 is equal to 14 meter per second square. So this is the acceleration with respect to ground, right? Copy this. So very important and very interesting question I'm going to explain. Suppose this is the liquid. Liquid means it is water. Suppose this is the water. The density of water is rho w. And there is a ice piece, right? This is the ice cube. Are you getting or not? Like this. You have to tell when the ice is melt. When ice is melt completely, right? The level of the water will rise or fall. Find whether level of water, this is the height, right? This is the height. The level of water will rise, will fall, or rise. This is the question. Do you know the solution or the answer? Only you have to tell when this ice is completely melt, the level of the water will rise or will fall. You tell. Let's see. Listen one thing. You tell me the density of the ice is less than the density of water. Is it clear or not? You tell. So when the ice is, suppose this is the ice, right? And when it melts, you tell me the volume of this water form will increase or decrease? It decreases. All right. Now this is the ice, and from the same ice, this is the water form. Are you getting or not? Such that the mass remains same. The mass of ice and the mass of water is same. Is it clear or not? What is the mass? So volume of ice into density of ice is equal to what? Volume of water formed into density of water. Is it clear or not? So if this is the volume of water formed will be volume of ice into ice upon water. This is the volume of water formed. Is it clear or not? You tell. This is the volume of water formed. So when this ice cube melt, the water will be forming. Are you getting or not? Now, in this case, what is the, if this is the mg, this is the volume V1, this is the volume V2, the mg and the Buoyancy force is acting. So what is the volume displaced by this ice? Can you tell me? The V1 is the volume displaced by the ice. In this case, right, I am writing here only, yes, I am writing this side. At equilibrium, the mg and Buoyancy force will be the same or not? Yes. Mg is equal to what? Total volume of the ice, density of ice into g. What is the Buoyancy force? Say m dash g, although gg will cancel out. So m is equal to m dash. The mass of the ice is the total volume of ice into density of ice. Is it clear or not? You tell. What is the m dash? M dash is the mass of the liquid displaced. You tell me. What should I write? The V1 into density of water. So the V1 is equal to what? volume of ice into rho of ice into rho water. This is what? Volume of water displaced. Water displaced. Volume of water displaced by ice. Is it clear or not? Tell me. This is the volume of the water displaced by the ice, and when the water is formed, the water form volume and volume V1 are same or not, you tell. What does it mean? It means, listen one thing, this is the volume outside the air, this is inside the volume inside the water. So when it compact, when the ice melt and the water is formed, the volume is compact. So all this volume is combined with this volume only. So all the water will come in this V1 volume, because the water volume formed is equal to the volume of the water liquid displaced or the water displaced. Both are equal. So what will happen? When the water is forming, the level will remain same, only this, it will be the extra water, right? This is the volume of the water. The volume will be occupied by the water formed is same as this V1. So no level change. So therefore the volume of the water displaced is equal to volume of the water formed. Therefore no change in level, no change in water level. You understand? This is a very important thing. So this question may be asked like this. For example, if there is a body, right? There is a body and which is floating like this, right? And there is a coin. This is the coin, right? It is inside the body like this. If this coin is dropped into the water, you tell me what will happen to the level of water. Tell me, if this coin, right? If this coin, this is the water. If this coin falls in water, effect on level, water level, it will rise, it will fall down, or it will remain same. You tell. What? It will remain same, it will fall down, it will rise. So let's see the calculation. Just previous to this question, the previous lecture, I gave you the concept that if this is the ice cube, right? This is the ice cube. When it melts, so what is the effect on the level of the water? So it remain same. But in this case, it will not remain same. So let's see what happened. How it is, listen one thing. When this coin falls here, right? When this coin falls here, so what will happen? You tell me about this wooden block. Suppose this is the wooden block. What will happen? It will come up or go down. If it is come up, right? Suppose the coin is in the air now. It is in air. So what will happen to the level of the water? You tell. Repeat, look into the figure. When this is the wooden block, come outside from the water, then what will happen? It will go down. Is it clear or not? You tell. It will go down or not? Tell me. Why? Because this is the portion. When this mass m is placed, right? When this mass m is placed over this, it will move up, right? And this is the this is the volume of the water displaced by this coin. Is it clear or not? And this is the volume. Is it clear? So when you move up, when you move this coin from the wooden block, what will happen? It will come up and this is the portion, right? This is the portion. This volume go to this side. Is it clear or not? You tell. Right? This is the volume. Go to this side. Is it clear or not? You tell. So now the water level will rise or fall. After removing the coin, the water level will say fall down. Is it clear or not? In this case, listen one thing. In this case, when you put the mass m, what is the condition? What is the volume displaced? This is the volume displaced by the coin. If you put the coin on this, it will go down. So this is the volume displaced, right? And this volume come over here, right? So what is the condition? The mass mg, the Buoyancy force, the volume displaced by the coin. What is the volume displaced by the coin? You have to find, right? So you will apply the mg. The mg is balanced by the extra Buoyancy force, and this Buoyancy force is what? Volume into density of water, right? Into g. I will write in this way. This is the m dash g is equal to mg. Gg will cancel out. This is the m. This is the volume of the displaced liquid. Volume of the displaced liquid into density of water. This is equal to m. So volume of water displaced by the coin is equal to Vw. So what is the volume of the water displaced? Is equal to m upon root w. So this is the volume, right? This volume and this volume both are equal, and it is the water displaced by the volume, right? This is the volume displaced by the coin when, if you put this coin on this wooden block. Is it clear or not? Now this is the volume. Suppose this is the volume. This is the V1 volume. Is it clear? Combining volume. Now when this coin is go inside in this water level, this is the water level. You tell me, suppose before, when it was the wooden block, it was the X, right? Outside the air. So when the coin falls, what will happen to the water level? Tell me. The water level will rise little. Is it clear or not? If the coin falls over here, the water level again will move up by some displacement x dash, suppose. This is the again move up. But if you consider the condition of the equilibrium of this block, so this block will remain same, because the mg and the Buoyancy force will acting on this body, and here the mg and the Buoyancy force will be acting in the same way. So this portion x outside the liquid of this wooden block does not change. Only what happen when you will fall the coin in this water, so the volume is displaced by this coin, and because of this volume displaced, the level of the water level is increased. You understand? So what is the volume displaced now when coin falls in the water? What is the volume? What is volume displaced? Volume displaced by coin. The volume displaced by the coin is same as the volume of the coin itself. Volume displaced by the coin is equal to volume of the solid itself. So what is the volume? If the mass is m, volume of the solid and density of solid. So what is the volume of solid? Mass upon density of the solid. So if this is the mass upon density of solid. So this is the volume of the, again the volume displaced by this coin, right? So if you consider this is the small volume, this is the volume equal to the volume of the coin. Is it clear or not? So when you put the coin on the wooden block, what is the volume displaced? This is the volume displaced. When you fall this coin, right? So what is the volume displaced? This is the volume displaced. So tell me which is greater, since the density of solid, the coin is density of greater than the density of water. This is greater, so this volume S is less than the volume displaced in this case. So listen one thing. So initial it was the level, right? It was the level of the water. When you remove the coin, the water level down, right? When this coin falls in the water again, the volume level is up. But this is the very small portion as compared to this. So ultimately it is the initially level and this is the final level, right? So in this case the water level, right, since the volume displaced by the coin, right, in this case is more, is more, V1 is more as compared to the volume displaced by the coin when it falls in the water. So finally the level, water level will fall in this case. Is it clear or not? Copy this.